Have you ever sat under a clear blue sky and wondered, why is the sky blue? It feels like such a basic, everyday question. Most of us think we already know the answer, some vague memory of hearing light scattering in school. But what if I told you, the sky isn't actually blue? Mind-blowing, right? Well, today, we're diving into the real science behind it. And trust me, you will never look at the sky the same way again. Let's start with the most straightforward fact. When sunlight passes through the Earth's atmosphere, the air scatters short wavelengths of light, like blue and violet, across the sky. This scattering effect is called Rayleigh scattering, named after Lord Rayleigh, the scientist who uncovered it in the late 19th century. But here's the catch. Violet light is scattered even more than blue light. So if that's true, wouldn't the sky appear violet rather than blue? Hold on to that thought. It's going to get more intriguing. Now, before I sidetrack you with violet, let's establish something important. Sunlight itself doesn't look blue when we see it directly. It's white. What does white mean? Well, white light is a combination of all the colors in the rainbow. Just imagine shooting sunlight through a prism. Those reds, oranges, yellows, greens, blues, indigos, and violets, they split apart like a color parade. When this white light hits the Earth's atmosphere, it interacts with molecules of nitrogen, oxygen, and even tiny particles like dust and water droplets. The smaller the particle, the more it scatters short wavelengths, which is why blue and violet dominate the visual field, smothering the reds and yellows. But again, why isn't the whole thing violet? Here's the answer. Humans have a unique limitation. Our eyes are designed with 3 types of color receptors: red, green, and blue cones. Sure, your blue cones are great at detecting blue light, but they're not especially sensitive to violet. On top of that, sunlight itself contains less violet than blue, which lowers violet's impact by the time it reaches us. So the blue scatters like crazy, and voila, our brains decide the sky is blue. Now, are you still with me? Because we're about to get even weirder. The sky that you see is not the same sky that I see. What? Yes, perception isn't universal. Take animals. Bees, for instance, can see ultraviolet light. For them, the sky would reveal ultraviolet patterns beyond human sight. And speaking of sunsets, that moment when the sky turns gorgeous oranges, pinks, and reds, it's a byproduct of longer wavelengths dominating when the sun is lower in the sky. The blue light has to travel a greater distance through the atmosphere, so it gets scattered away, letting red and orange light take center stage. But remember, that orangey-red wash over the horizon, that's not the real color either. You're probably asking now, is there even such a thing as the real color of the sky? Well, physically speaking, the sky doesn't have a color. That's right. Objects and gases in the sky only scatter light. This constant scattering creates an illusion of blue, or orange, or gray during storms. Perhaps this realization begs the philosophical question: how much of what we see is subjective? If the sky's color changes based on your angle, time of the day, and biological constraints, then who's to say what's real? But what's going on beyond Earth? Let's float a bit higher, into space. From the International Space Station, astronauts don't see a blue sky. Why? In space, there's no significant atmosphere to scatter light. Instead, they see the inky blackness of the universe punctuated by a blazing white sun. That sharp contrast reminds us that without scattering, there'd be no color of the sky to discuss. Our atmosphere, it turns out, gifts Earth with its visual drama, and a unique signature that's just one part of why our planet feels alive. Are you still wondering how all of this applies to other planets? Let's look at Mars. The Martian sky can appear reddish-pink during the day, owing to iron-rich dust particles blowing through the planet's thin atmosphere, scattering sunlight differently than Earth's nitrogen-heavy air. Surprisingly, Mars also boasts bluish hues at sunset instead of red. Isn't that trippy? It's all relative to how particles and light interact. Suffice it to say, a Martian tourist would have a completely different conversation about sky color. Right now, as you gaze back up, think about this. When you see that hue above you, you're participating in one of the most elegant collaborations between physics and perception. Water droplets take part in it too. On rainy, cloudy days, light can scatter off these larger airborne particles in ways that make the sky appear gray and dimmed, a stark contrast to its sunnier counterpart. And those brief moments when sunlight bursts through storm clouds? Clouds act as prisms in their own right, splitting and redirecting the light into rainbows for your eyes to catch. Astonishing, isn't it? Each weather condition adds an atmospheric layer to the unassuming question, what is the color of the sky? If your inner scientist wants to learn something hands-on, consider this experiment. Go out during twilight and try to track how blue fades into orange and pink. Take snapshots and compare them. You'll notice that the gradient isn't static. Clouds, particulate matter, and pollution tweak the palette second by second. Humans have an advantage here because of our ability to recognize patterns and notice subtleties beyond the mere physics behind it. Point that out to a child or a friend next time and see their reactions. Physics doesn't stop surprising us. What seems daily and ordinary often hides layers of brilliance. The next time you glance upwards, whether you notice a beautiful azure hue or a brooding gray creeps in, remember, the truth behind it is as vast and infinite as space itself. Isn't it incredible that something as simple as, why is the sky blue, turns out to have so much complexity and depth? So now you know the big secret. The sky isn't blue, violet, gray, or indeed any color at all. It's a blank canvas, waiting to scatter light and mess with our perceptions. But that's just part of its charm, isn't it? With every glance, the sky tells a slightly new story, even though its essence remains the same. It's our eyes turning into storytellers, weaving light and physics into art. And while technically you now know the science, here's the poetic part. The sky's illusionary colors belong to you, shaped by your viewpoint, your moment in time, and your endlessly curious human brain. Now, next time someone asks you, why is the sky blue? Or even suggests the sky is blue, you'll have a cheeky grin. Because now you know it's not the complete picture. Why accept something small when the truth is endlessly expansive? Don't forget to share this mind-blowing fact with someone else. After all, who doesn't love having their perspective shaken up a little?